This is the video notes for Unit 9, Lesson 6, Food for Thought. And it is a develop understanding lesson. And it starts off by introducing someone named Aaliyah. Aaliyah loves to cook and collect recipes. She started her own food blog to share her love of food and passion for cooking. She hopes to build up a following and to eventually get sponsors so that her blog can become a source of income. The web service that hosts her site provides some data analytics that she likes to look at to make decisions about future posts. Last week, she collected this data. The first set of data shows the number of visits to the site each day, starting with Monday. The second set of data shows how many recipes of each type were downloaded during the week. So let's go ahead and just look at them for a moment. We're going to do 2 notices and 1 wonder. So something that I'm noticing is that they're both bar charts, right? Bar charts can also be called histograms. Okay, so I'm going to say both are bar charts. Okay. And then which can be called histograms. Okay, so I guess that's my notice. I'm noticing their bar charts and noticing that those are also called histograms. And my wonder is what the data looks like before it got graphed here. What does data look like? Okay, so that's my wonder. Okay, let's go ahead and do number 1. It says, compare the 2 displays of data. What similarities and differences do you observe? All right, so if we compare them, I'm missing an E over here. If we compare them, it looks as if this left one doesn't have gaps in the data, in the bars. So I guess that's something. Here, I'm just gonna point to it. So they both have bars, but on this one, the bars are together. And right here, this x-axis scale is numbers. So that's different between them, right? They both have bars. This one, the bars are together. This one, the bars are separate. I wonder if that's just a preference of like how you want to visually see it. Separate. And then on the left here, here's a difference. These are numbers, right, for the days and number of visits. And then over here, these are instead categories. Okay, so some bar charts, some histograms will have numbers on the x-axis, some will have categories. All right, let's go ahead and turn the page. So on the second page, we continue shadowing Aaliyah. It says, Aaliyah found that her most popular recipe was for her special chewy moist brownies. She checked the analytics and found that during the week, 30 people had checked out the brownie page. The next 2 diagrams both represent the data for the number of minutes that people spent on the brownie page. All right, so this is all about the brownie page, right? All right. compare the two representations of the data. So here we've got a histogram, right? And then over here we've got something called a dot plot. Okay, so histogram and a dot plot. What do you observe about the number of minutes spent on the Brownie page? So this is what I'm seeing. On the histogram, it looks like this is the most amount of minutes. And then on the dot plot, we can actually see every single person, right? And this is the most amount of minutes. So are they contradicting each other or agreeing with each other? I think they're agreeing with each other, except for here on the histogram, it looks like there's a group of numbers together, like from 15 to 18, it's all grouped together. Yeah, that's why that one would be the tallest, right? So we're going to say one observation is most people spent 15 to 16 minutes. Okay, and I could have said most people spend 15 to 18 minutes, but the dot plot actually gave me more detail, so I was able to, instead of saying 15 to 18, I could say 15 to 16. And then you see that there's like this gap here between 10 and 12. So that's confirmed right here, isn't it? Between 10 and 12, nobody came. Even 13 and 14, which is strange to me that it has a bar. I wonder if 12 to 15, I wonder if this 15 is included in this lower bar right there. Interesting. So I'm just going to go off what I'm seeing from the dot plot. It has more details, right? We see every single data point. I'm going to say no one spent, and I'm going to even include these other timestamps where we don't have any people spending that amount of time. No one spent 4, 7, 8, 10, 11, 12, 13, or 14 minutes. Okay, so I think that's a good amount of observations. What aspects of the data are highlighted or obscured by each representation? So let's talk about the histogram first. Histogram. So I'm kind of feeling like on the histogram, the data is grouped in bins, right? That's pretty obvious. So that could help if we have a really, really big data set. Data grouped. In bars. Sometimes they'll call those bins. So this is really good if we have a really huge data set, and we don't want to see every single point. So it's nice for large data sets to use a histogram. Let's talk about a dot plot. In a dot plot, this is pretty good for small data sets because you can see every data point. Can see every data point. And we're going to actually start talking about different features of these representations, and one of them is the median. And on the dot plot, it's actually pretty easy to see the median. Easy to see median. Just a reminder what the median is. It's the physical middle number of the list. So if I were to look here at the dot plot, I'm gonna erase. It won't let me. Okay, so let's just change my color. So if I were to try to find the median, it already tells me the median is 15, but I would count inwards, right? So this is 1, 2, 1, 2, 1, 1, until I got to the physical middle of the list. One, two, three, four. 1, 2, 3, 4. So the physical middle of the list is actually 2 15s. It's these two right here. When you have two numbers sharing a median, all you do is add them. So I would just go 15 plus 15 and divide by 2. And that is 15. I know, shocking. All right, so median is easy to see. All right, let's move on. Aaliyah's math teacher said that there's one more representation that she should see. The box plot, sometimes called the box and whisker plot. Compare the two representations of the data. What aspects of the data are highlighted or obscured by each representation? Okay, so again, the one on the left is a histogram, right? So I'm going to label it a histogram so that we know what that one's called. And I will show in a minute, I think it's problem 5, how to hand draw a histogram. And the one here on the right is a box plot, okay, or box and whisker plot. So I'm going to focus more on the box and whisker plot for number 3. One thing I do want to draw attention on the histogram right here, it shows us pretty clearly where we have no data. No data. So that's kind of helpful for the histogram. Whereas the box plot doesn't really show us a gap in data everywhere, and that's just because of how it's organized. So on a box plot, these are the attributes of a box plot. It is broken up into 4 quartiles, and I will tell you what those are and how to find them. So let's do a little thicker line. There we go. 4 quartiles. The 4 quartiles are the data is being split into 4 quarters. That's why they're called quartiles. And when you have the data split into 4 quartiles, you actually end up with 5 values, right? So if you imagine this first value here is called our minimum. This one right here is called quarter 1 or quartile 1. This one here is the median. This one here is the third quartile, so quarter 3. And then this last one here is our max, our maximum. These 5 things are actually called the 5-number summary. Okay, so it's 4 quartiles and it's called the 5-number summary. Right, that's minimum, Q1, median, Q3, and then maximum. Something else that we can find from a box plot is something called the interquartile range. Interquartile range. And usually that's abbreviated IQR. And it's just a quick way of talking about how spread out the data is. And the interquartile range is just the quartile 3, whatever that number is, minus quartile 1. Okay, so let's pick out some information for this. So if I were looking at this box plot, I would say that the median is right here, I would say it's 15. I would say the first quartile is 6. I would say the minimum was 1. I would say quartile 3 was 16. And then I would say the max was 18. So that would be my 5-number summary. It would be 1, 6, 15, 16, and 18. My interquartile range would be 16 minus 6, so it would be 10. And those would be the things that I would be looking for. Now, before I move on, I want to just do an example of, given a data set, how to find these 5-number summary. Okay, so I'm just going to do a set of data completely unrelated to this box plot. So this is going to be our 5-number summary example. Okay, so let's say I have the data 1, 2, 2, 4, 7, 8, 8, 9, 13, 14. Okay, so let's actually add one more. Let's do 17. So this is how you would find your 5-number summary to build your box plot. You first need to find your minimum and your maximum. So obviously this is your minimum right here, and this is your maximum. Now once you've done that, then you need to work your way in to find your median, right? Because your median is the middle number in the data set. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Well, that's kind of nice. We have a definitive middle number. It's this first 8. So that is our, so this is our minimum. This is our minimum here. This is our maximum. This is our median. Okay, now we want to find our Q1 and Q3. So our Q1 is the middle of this left half of your data, right? So we're going to work our way in. So 8, 7, 4, 1, 2, 3. It looks like these two right here share the middle of the left half of the data. So all I would do is I would do 2 plus 4 divided by 2. So that's 6 divided by 2. So 3 is my Q1. And then over here on the right side, I want to find my Q3, which is the middle of my upper half of my data. So I would kind of count my way in. Okay, again, I've got 2 sharing the middle. Sometimes that happens. So all I'll do is just take the average of them. So 9 plus 13 divided by 2. So that's going to be 22 divided by 2 is 11. So 11 is going to be my Q3. Now when I go to graph this box plot that I've been working on getting my 5-number summary for, I would do a number line, right? And then I would want to make sure that it counts, includes my lowest and my highest, right? From 1 to 18. So I'm just going to start here, 1 to 17. And then over here, I'm going to do my 17. And let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think I need to build it a little bit further to the right. So let me extend it. 5, 10, 15, 16, 17. Okay, so then I'm going to do my box plot, right? So at the minimum, let me just put a dot or a line. They like lines in this lesson, so we'll do a line. At my median, so that's 8, put a line. At my Q1, 3, put a line. And then Q3, 11, put a line. And then at 17, okay? And then the middle 3, I'm going to put a box around. And then I'm going to put whiskers going out to my min and my max. Okay, so this would be the box plot that represents the 5-number summary for this example data set. All right, let's move on now to to the next page, page 231. All right, it says, Aaliyah likes histograms and wants to use them more. She asked her math teacher what she should be looking for when she examines a representation of numerical data. Her teacher said that she should look for 3 things. Okay, so the very first thing she should look for is center. So the center is like the middle of the data, right? So that's the first thing that she should be looking for is center. The second thing that she should be looking for is shape. And the third thing she should be looking for is spread. So I'm going to talk about center first. The 2 measures of center that we will be studying are the mean and the median. And I'm just going to go over really briefly what each one is. So the mean is the average, right? Mean is the average. Just a reminder how to find the average. You add up all the numbers and then divide by how many there are. So if I were going to find the mean of this data set that I did as an example on the previous page, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I would add them all up and I would divide by 11. Okay. The median, I already demonstrated on the previous page, but I'll just write it here. The median is the physical middle number, right? You just count from one side in and the other side in until you get to the physical middle number. All right. So that takes care of measures of center. Now let's look at our second thing to look for. It's called shape. So there are lots of different shapes to data, and we're going to focus on shape here for histograms. So when you see a histogram that looks like this first box, it's called skewed right. So we're looking where the tail of the data is, like the smallest amount of data is. So that is what dictates that it's skewed right. That's where the tail is. We have skewed left, tail is on the left, symmetric. It has like a hill in the middle, and then left and right goes off symmetrically. Bimodal is where we have a hill on the left and right, but in the middle there's a dip. Uniform is when it is flat. So those are our different kind of shapes. They're the most common. Our third thing to look for is called spread. This tells us how wide or dispersed the data is. Measures include the range and the mean absolute deviation. So the mean absolute deviation it says we're going to talk about that in the next lesson, so we won't worry about that. But I'm going to quickly talk about the range, just so that you have it in your notes. You know how to find a range. So a range right here is found by doing a subtraction. So range is the maximum minus the minimum. Okay, that's all you do to find a range. Max minus min. All right. Without using technology, number 4, sketch a data distribution with the following characteristics. All right, so let's do a few sketches. A histogram with 7 bins that is skewed right. Okay, let's go ahead and do that. So I'm going to do our little X and Y axis. Let's just have this count up to 20. And over here, we'll go 1, 2, 3, 4, 5, 6, 7, 8. So we need it to be skewed right. Remember, the way that it's skewed is where the tail is. So there's going to be less data on the right. So it's going to be pretty tall here on the left. So let's do our first bin. And then we'll just progressively get smaller to show our skew. 1, 2, 3, 4, 5, 6, 7. Okay, part B, a box plot with a median of 5 and a range of 15. Okay, so we need a number line. And then the median is 5, the range is 15. So let's just go by 5s. 10, 15. So I'll put a minimum at 0, a maximum at 15, right? That's my range. And then my median is 5. And it doesn't tell us where Q1 and Q3 are, so I'm just going to kind of put them right there, do my box, and then do my whiskers. All right, part C. A dot plot that is mostly uniform and has an outlier. Okay, so for a dot plot, we need a number line. And then we're just going to go 1, 5, 10, we'll go by 5s, 15, 20, and we're going to make it uniform, pretty flat. 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's pretty uniform, right? It's they have the same amount per of data for 1, 2, 3, and 4, and then let's put an outlier over here. Okay. All right. D, a bimodal histogram that is not symmetric. So we want it to be bimodal, but not perfectly symmetric. Okay, fine. So let's do our X and Y axes like this. We'll go up to 20. We'll put a 10 there. And then 1, 2, 3, 4, 5, 6, 7, 8. So we want it bimodal. So that has a dip in the middle, right? So this will be my dip in the middle. And then it has some taller, but I'm not going to make it symmetric. So taller, but not symmetric. And then I think that's good. It's bimodal, but it's not symmetric. Awesome. All right, let's move on to number 5. For number 5, we're going to practice creating a histogram. We've practiced creating a box plot. We did not practice creating a dot plot, but that's pretty easy. You put a dot above every value in the data set. So this will be our final example here on how to create a histogram. All right, it says to use technology. So it says Aaliyah found data for the number of minutes that people spent browsing her recipe blog. Use technology. So we're not going to use technology. We're just going to do this by hand. Okay, we're just going to create a histogram, and we want 5 bins. We want to describe the center, the shape, and the spread. Okay, awesome. So looks like it goes from 2 to 20. So how do I split that into 5 bins? So I'll just take the max 20 and I'll divide that by 5. So it looks like every 4 we're going to have a new bin. So, or a new bar, bin, bar, same thing. So let's show how we do our 5 bins. So our first one is going to be from 1 to 4, then from 5 to 8, and then 9 to 12, and then 13 to 16, and then finally 17 to 20. Let's count how many are in each of these bins. Looks like from 1 to 4 we've got 3. Then we've got from 5 to 8 we've got 6. 9 to 12 we've got 6 again. 13 to 16 we've got 13. And then in the last bin we've got 12. Okay, so let's go ahead and draw it so we can describe the center, spread, and the shape, or center, shape, and spread. All right, so we've got our x and y axes. So the fourth bin here has 13. That's the biggest. So I think I'll go up to 15, and I'll just go by fives. So 10, 5, and then we need to go all the way to 20. And I'm going to just label each of my bins with these categories. So like right here, this is going to be 1 through 4. And the next one is going to be 5 through 8. And the next one is going to be 9 through 12. The next one, 13 through 16. And then my final one, 17 to 20. Okay, so each of my bars, my bins, will just have that range. So it looks like I've got 3, my first one, so that's right about here. That's my first bin. And then I've got 6, so it's going to be above. And then another 6. And then 13, that's really high. It's like here. And then 12, so one less. All right, so there is my histogram. Okay, so let's talk about our center, our shape, and our spread. So the center can be described using either the mean or the median, right? So to get the mean, what I did was I added them all up, and then I divided by how many there are, and I got 13.175 minutes. To find the median, if I use that as my center, all I did would be to count from the one side to the other side and count inward until I got to my physical middle number, which was shared by two 15s. So the median, 15 plus 15 divided by 2, would just be 15 minutes. Okay, now we're going to do the shape. So this is definitely skewed. Which direction is it skewed? The tail is on the left, so it's skewed left. Okay. Next one is our spread. Remember, the spread is just, as far as we know now, it's just the range, right? We're going to learn another way to describe the spread in a moment, but, well, not in a moment, in the next lesson. But for this problem, we're just going to use the range. So the range is going to be the biggest minus the smallest. So 20 minus 2. So that's going to be a range of 18 minutes. So that's pretty spread out. Okay, so that is number 5, how to build a histogram. All right, let's go ahead and do our takeaways. So single variable quantitative data. So that's what we've been studying. We've been studying data that has a single variable, which was different than our first learning cycle. That was 2 variable data. This is single variable data. So what type of representations did we go over? We went over a box and whisker plot, or you can just call it a box plot. That also works. Okay, so a box and whisker plot. We also went over a histogram, which is also called a bar chart. Here I'll put by box and whisker, that it can also just be called a box plot. Okay, and then the last one that was part of this lesson that we didn't have an example for, but they're really easy to build, was a dot plot. Remember, a dot plot, you just put a dot above each of the data values on a number line. Okay, what were the features that we looked at? So the features that we looked at were center. So the options for center are the mean and the median. We also looked at the shape. That was our second feature that we looked at. And we saw lots of different shapes in on page, I think it was 231. So the shape options are symmetric, skewed left, skewed right, uniform and bimodal. Uniform and bimodal. Okay, and then the last feature is called the spread. And in this lesson, we only talked about the range. That was just the maximum minus the minimum. We also did talk about, for box plots, the interquartile range, right? That was Q3 minus Q1. There's other ways of describing spread that were not covered here, but we'll add them to our list. So they are the mean absolute deviation and also the standard deviation. Let me put that over here. Standard deviation. So there are 4 ways to describe spread. So far, we've got 2 of them. Okay. Here's our long vocabulary list and our lesson summary. In this lesson, we focus on single variable quantitative data. We compared histograms, dot plots, and box plots to consider what aspects of the data are highlighted. We learned to look for the center, the shape, and the spread of the data. All right, I hope this lesson helps you with your practice, and I wish you good luck.